Hi class, we are now starting chapter 3 and we're going to cover 3.1 to 3.3. Sometimes in the beginning of chapters it's mostly a story, so I tend to skip over some of it and start actually getting into the depth of what you need to learn. So that's why this is not really a long lecture here, but sometimes I just skip over the introduction of what they're talking about, but you definitely should at least read it. Okay, so atoms and molecules, everything that we come into contact with, everything is made up of atoms and molecules, and we're going to start looking at that. We look at it as matter. So it's a really cute picture, atoms, molecules, goes eventually to matter, which is a cute little puppy. Matter is made of material that makes up all things. Anything that has mass and occupies space is considered matter. We're going to start looking at classifications of matter to begin this. And we'll come back to this here. This is something we are going to learn, but not at this moment. So again, matter is anything that occupies space and has mass. Is composed of atoms, and an atom is the smallest unit of an element that retains the chemical properties of that element. What does that mean? That means that, look at this aluminum can. Aluminum has certain properties, and those properties affect its behavior. If you keep looking at this can, and if you can visualize going into layer by layer by layer, until you get to a mound of aluminum atoms, and then you keep going and moving those away till you get to one atom. That is the smallest unit that is that retains the chemical properties of aluminum, the aluminum element. That means that if I break that atom open, it is no longer considered. It is still part of the atom element, but it does no longer retain the chemical properties that the aluminum element is known to have, and it affects the behavior. So we get down to that one last atom, and that is why it's called the smallest unit. If we break the atom open, we're now looking at subatomic particles. They don't retain the aluminum element properties or behavior. Atoms are also can be joined together, and this is what they're called as molecules. Molecules are composed of two or more atoms bound together in discrete arrangement. What that means is a fancy way of saying that things that we are familiar with, they are always bound in a certain way. Water is a perfect example. Water, no matter where you go in the world, is H2O, 2 hydrogens, 1 oxygen. That is what it means by discrete arrangement. If you have 2 hydrogens and 2 oxygens, it is now hydrogen peroxide. So it has to be in a specified arrangement of certain molecules, made up of certain molecules, for it to be that certain compound or substance. So H2O, water, that is what it is. You cannot change it. You cannot remove a hydrogen. You cannot add a hydrogen. You make it something else. So we are going to look at different classifications. One of them, you can look at composition, which that's what we're going to look at next. But for now, we're only going to look at physical states of matter. So the common states of matter for this course are solid, liquid, and gas. That's how we're going to classify it. Water is a good example of a substance that exists as all three. Water exists as ice, that's the solid. It exists as a liquid, and it exists as steam. So in ice, the water molecules are closely spaced together, and although they vibrate about a fixed point, they do not generally move. What that means is that if you are holding hands with a group of people in a circle, you have to stay in the spot that you're in. You cannot move from that spot. You are not free to move that spot. The only thing you can do is pretty much swing the hands with the person you're holding hands with. You also cannot let go of that person's hand. That's the vibration. That's what they're talking about. That these fixed water molecules cannot move from where they are. They are in a certain pattern, but they can pretty much move their hands, which is what we call vibration, but they can't do anything else in a solid state. In liquid water, water molecules are closely spaced, but they're free to move around, and they can move past each other. This is more like if you're standing by somebody, and you can move from that spot as long as you hold onto their shoulder, and if somebody else walks by, you can move, put your hand on that shoulder, and you can keep moving as long as you're touching somebody else's shoulder. So you no longer have to stay in one spot, but you still have to stay in contact with another person. In steam, you don't need that. You are on your own. You can walk around wherever you want very quickly. You do not need to be in contact with somebody else. You are free to move as much as you want. So that's what we're going to look at. You can see here, would be in a very fixed pattern. They are touching, but they're free to move. And these are isolated from each other. They're just doing their own thing. So states of matter, we're going to categorize this. So chemistry is the study of properties and behavior of matter. Matter again is anything that has mass and occupies volume. It's composed of particles. Particles are either atoms or molecules. They exist in three physical states. Solid has a definite volume and shape. That means that anything think of a desk that you're sitting at. That desk is made up of atoms or molecules, and it has a definite shape. You cannot change that shape unless you break that desk, but it's going to stay. You can slam your hand down, you can do whatever, but it's going to give you resistance because those atoms are stuck in a fixed position. They are not moving, and you cannot change it unless you're all breaking that desk. So a fixed solid means they're stuck in place. They can vibrate, but they can't move. A liquid has definite definite volume, but a shape is determined. What that means is that, again, they can move freely as long as they're touching each other, but so that's the volume, but they can take different shapes. You can pour water into a certain container and you can see how far it'll fill up. You can take that now container and change it to another container, and the water will still go into that container now, and it will take the shape of whatever that container is. That's what it means by shape determined. I can pour water into a vase that's circular, and then I can pour that water into a vase that is square, and it will take the shape of whatever it's being held in. Gas volume is volume and shape determined. What this means is that gas molecules move this depiction I have is very, very slow. They move very, very quickly, and they try to expand as much as possible. So they will take the shape and volume of whatever they're in. For instance, if you've ever been in a room and you're on the opposite side and somebody walks in with perfume, you're smelling that perfume even if you're far away, because that's a gas, and the molecules are trying to expand until they hit resistance. So that's what's happening. They will take the shape and the volume as long as they don't hit resistance, and once they hit resistance, then that's the shape and volume that they're going to take in. So solids have definite shape and definite volume. Particles are close together in a fixed arrangement. You can see a nice depiction here. None of these atoms are going anywhere. They can't move from the spot. The only thing they can do is pretty much, if you're holding hands, they can move the hands, but they cannot break that holding hands. They can just swing them. They move very slowly, and they have definite shape, definite volume. You cannot change the shape and volume of the desk you're sitting at unless you actually break it. We look at different types of solids. We have crystalline solid. These are atoms or molecules are arranged in geometric patterns with long range repeating. This simply means that they have regular repeating patterns. The atoms fit very nicely and organized together, and you can see that's where the word crystalline, that's where salt comes from. Have you ever looked at a salt crystal? It's very nice looking. And diamonds are another crystalline. They kind of have a clear, shiny surface to them. That's because of the long range repeating order of everything. It's very nice, clean, repeating, organized shape. We have amorphous solid. Atoms or molecules do not have long range order. This means that there's a regular pattern. If you look over here, looks like it's thrown together however it is. And think like a pile of clothes. You keep throwing clothes, you're not folding them, you're just throwing them together. And because of that, they do not have that nice, clean look to it. It's just a random pattern, no pattern at all, pretty much. So with the crystalline solid, they are well ordered. They have nice geometric shapes. The salt and diamond crystals reflect how well ordered that is. And so you can see here in amorphous that include glass, rubber, and plastic. So here's a salt crystal. It's kind of a little shiny. It looks different than this, and that's because of the repeating pattern that it has. It's well ordered. It has a good arrangement of the atoms. It's very organized. Liquids have an indefinite shape but a definite volume. This means that a liquid will have a definite volume. So there'll be a certain amount in there, but it will take the shape of whatever container it is going to be held in. So it have an indefinite shape but definite volume, the same shape as the container. Particles are close together, but they're free to move. They can move around with some freedom, but they have to be touching other molecules. And then gases have indefinite shape and definite volume, the same shape and volume as their container. And gas molecules are on their own, and they will just move very quickly and very fast until they hit resistance, and then they will just fill in that whole container of whatever it is that they're in. The particles are very fast. They actually don't like to come into contact with each other. They are as far apart as possible. So if you put air into a balloon, those molecules in that balloon are hitting the sides of it and then they're just bouncing off and going into another direction and hitting that. They will keep moving around in it. Again, perfect example of a woman coming in or a man wearing cologne. You will eventually smell that in a room because those gas molecules are leaving and they're trying to expand out as far as they can. So this is from another book, another class I have. I like it better, the table, than what's in your book. It gives a breakdown with more information. So let's take a look at this. So we have characteristics. Let's look at solid. Solid has a definite shape, has a definite volume, and that's because the particles are very fixed. They cannot move. They can vibrate, but that's pretty much all they can do. They have very strong interactions between the particles. That's what keeps it a solid. That's what makes it hard to break apart, is that strong interaction that they have. So think of holding hands with just a grip that nobody can break. They move very slowly because they can't really move. There's not much they can do. And examples are ice, salt, and iron. A liquid takes the shape of the container. It has a definite volume, so there's a definite amount in there, but it will always take the shape of whatever container it's in. The arrangement of particles are random, but they're still very close. There's an interaction that is strong. It's still strong. The molecules may have more freedom, but they're still interacting with each other, and it's not easy to break them apart. The movements is moderate. They can move, but they don't move as fast as a gas and not as slow as a solid. And examples, water, oil, and vinegar. A gas takes the shape of the container, and the volume fills the container, the volume of the container. And that's just because these molecules will keep expanding and keep going in all directions until they hit resistance. So it's random, the arrangement's random and very far apart. There's really no interaction with particles. They try to avoid each other because they're simply just expanding in all directions. They move very fast. Water, vapor, helium, and air are examples. So let's go through this to make sure you guys understand. Identify each description as that of a solid, liquid, or gas. It has definite volume but takes the shape of the container. That would be a liquid. So definite volume but takes the shape of the container. Its particles are moving rapidly. That would be a gas. Its particles fill the entire volume of the container. That is also a gas because the gas will expand until it hits resistance. Its particles have a fixed arrangement. That's a solid because it can't move. Its particles are close together but move randomly, and that's water. That's liquid. They can still move, they can take the shape of a container, but it definitely has volume. Okay, so identify the states of matter, solid, liquid, or gas, for each of the following. Vitamin tablets. That would be a solid. That's not a liquid, it's not a gas. Eye drops, that's a liquid. Vegetable oil, that's a liquid. A candle is a solid. And air in a tire is a gas. And that's it.